One thing I struggled to understand for a very long time were the differences between low and high dose aspirin. This is because they just seem to have completely different functions, although they're both the same drug. And so, in this video, I want to finally break down what these differences are and why these differences come about based on aspirin's mechanism of action, and hopefully this concept will stick and make a lot more sense after this video. So let's just begin with what these differences in indication are based on the dosage of aspirin. So low dose aspirin is used generally in elderly patients with cardiovascular risk. Low dose aspirin is extremely common. If you're over 40, you have a 1 out of 4 chance of using this product, low dose aspirin. And actually, you can tell a lot about the indication of low dose aspirin just by looking at the product itself. You'll notice that 81 milligrams is surrounded by this nice heart, and that's because it's also referred to as the heart dose. Aspirin is in low doses is meant especially for patients with heart diseases because it prevents your myocardial infarctions. In the product right below, we see a intermediate dose aspirin with 500 milligrams, and intermediate dose aspirin is generally considered as an antipyretic and an analgesic, which means that it's a fever reducer and a pain reliever. You'll also notice that I didn't include a product for high dose aspirin, and this is because high dose aspirin is actually rarely ever used today, and this is because high dose aspirin is going to cause GI ulceration to a much higher extent than other NSAIDs, and so if we ever need the anti-inflammatory effects of an NSAID, we're not going to choose aspirin, but we're going to choose these more well-tolerated NSAIDs, and I'll explain to you why that is as we move on through this video. So if we go down here and we can see the classic arachidonic acid pathway. If you're in any form of a health science major in university, you'll be familiar with this pathway because inhibiting this pathway forms the crux of all NSAIDs essentially. Now aspirin is an NSAID, but here we have it separate since the focus of our video is aspirin. You'll notice that aspirin inhibits two enzymes, COX-1 and COX-2, which stands for cyclooxygenase. The difference between these two enzymes is that one enzyme is produced at all times in almost all your cells, and that's why it's referred to as constitutive, and it forms constitutive prostaglandins constantly to perform various physiological functions such as gastric mucosal protection, platelet aggregation, and increasing renal perfusion. I want to focus today on these two physiological functions because they have implications on how aspirin is used clinically. And with regards to COX-2, COX-2 is generally considered inducible, so it arises in states of inflammation and in injury. And what it does essentially is it acts as a natural biological response to induce prostaglandins that would increase pain sensitivity and accentuate inflammation. Based on what enzyme aspirin is inhibiting, we're going to have different effects of the drug. Now, I'm going to say a sentence which is going to be the most important sentence of this entire video, and that is that aspirin favors the inhibition of COX-1. This is why we have completely different functions between low doses and high doses, because aspirin is always going to favor binding to cyclooxygenase 1. And so therefore, if we have a low dose of aspirin, which is represented by this red circle, since we have a higher affinity to cyclooxygenase 1, we're going to selectively inhibit cyclooxygenase 1. Whereas if we have a high dose and we completely saturate all your cyclooxygenase 1s, we're going to be forced to bind to the lower affinity cyclooxygenase 2 enzymes. And if we inhibit the low affinity cyclooxygenase 2 enzymes, in that case we're going to produce the anti-inflammatory effects, which are going to reduce your fever and they're going to reduce your pain. You'll notice how I have thromboxane A2 written right here, and this is because when cyclooxygenase 1 is producing prostaglandins, these prostaglandins are further processed into thromboxane A2, which is released majorly by platelets. And this thromboxane A2 is actually what's responsible for platelet aggregation. And so if we inhibit the formation of this thromboxane A2, we're going to inhibit platelet aggregation. And if we inhibit platelet aggregation, we're not going to be forming clots in our blood, right? This would be your blood vessel, and we're not going to be forming these clots, and therefore we decrease the risk of myocardial infarction and any other cardiovascular disease. And now remember when I said that aspirin is the biggest cause of producing gastric ulcers? Well, that's because of this function that's being inhibited, gastric mucosal protection. Since aspirin is very COX-1 selective, and as a matter of fact, aspirin is the most COX-1 selective out of all the NSAIDs, and therefore it's going to have the highest impact on gastric mucosal protection and increase your risk of ulcers. So these were the major differences between low and high dose aspirin.